Thanks, Randy. Really appreciate it. And thanks to everyone for sticking on here and hearing about what's going on with the WSSI. Just a quick outline. Just some in the past, I've kind of gone over a very similar presentation on some of the mechanics of the WSSI and some examples. Today, I'm going to focus on some more topics, like what is and is not the WSSI. I'm going to get into some of the changes for 2020, talk about the website changes, the VLab updates. I'm also going to get into the Prob WSSI a little bit. And I wanted to, there's been a lot of comments and questions in the past month or so about the WSSI snow criteria. So I'm going to take a little bit of time and just show what the warning criteria is for the Weather Service and compare that to what the WSSI moderate looks like. I've got a link summary as well. So just kind of a slide that's to act as a quick reference guide for people looking for some of the more detailed information about the WSSI. And finally, a summary. So I do have to throw in my my overview slide here of the WSSI. Once again, the goal of the product is to summarize multiple winter weather impacts from a storm into an easily consumable graphic. It is based on 72 hours worth of forecast data that's broken into not only a 72-hour summary period, but 24-hour breakouts. So you get the day 1, day 2, day 3 effect. The data is coming from the NDFD, so I want to stress that this is your data. That this is not model data. This is just your raw output, raw forecast data, repackaged and just through these algorithms. As Dan kind of talked about earlier, I found that very interesting. Labeling not only a 1 through 5 alert system, but then pairing it with a color. That's what we're currently doing with the WSSI, ranging from the light blue limited impacts all the way up to the purple extreme impacts. And those impacts are going to categorize the 6 components of the WSSI, which are snow amount, snow load, ice accumulation, blowing snow, ground blizzard, and flash freeze. And then there's a final summary graphic, which is a composite of the maximum impact from any of the 6 components. And that summary graphic is kind of the first thing you'll see, and that's when you go to the WSSI web page, that's the first thing that's displayed is that overall summary impact graphic. So what the Winter Storm Severity Impact is. So remember that this is a tool to assist you guys in maintaining situational awareness of the possible significance of weather-related impacts based on your forecast, the current official forecast. It's a tool to help communicate a general level of potential societal impacts and their spatial distribution. And it's trying to highlight actionable information for partners in their goal to mitigate problems due to winter storms. What the WSSI is not. It is not a specific forecast for specific impacts. For example, it is not a depiction of a depiction of moderate severity does not mean schools will have to open or close. It is not meant to be the sole source of information about a winter storm. It should always be used in context with the Weather Service forecast. And the WSSI does not account for conditions that have occurred prior to the creation of time. It only uses forecast information. Therefore, during an ongoing winter weather situation, the WSSI will not be representative of the entire event. I want to linger here for just a second. When you're using the WSSI, remember it's always forward-looking. So a good example of this was in the ice storm that just hit Norman a couple weeks ago. That event, it kept always looking like there was just a major or moderate ice event ongoing, and that's because the ice accumulation forecast kept changing throughout the forecast. But because the WSSI is forward-looking, it didn't know that some of the ice accumulations were accumulating faster than had previously thought, and it was not taking into account those earlier the earlier accumulated ice amounts. So that's something to keep in mind, that as the forecast changes, this will update, but once you get past the observed condition, it's not going to know that it's happened necessarily, with the only exception being ground blizzard. Using non-meteorological with meteorological data, that is something that I wanted to highlight a little bit more as well. So the WSSI uses non-meteorological data along with the meteorological data to help forecast impacts. The non-meteorological data that we use, first off, is urban areas, which is used in the ice accumulation and snow amount index. And that gives a 25% increase to the impact, and those regions are defined from the U.S. Census Bureau data that was last updated in 2018 based on the American Community Survey. The land coverage and land use, so that's really used in the blowing snow and ground blizzard index. That decreases impacts for areas of reduced winds, for example, forest, high density commercial areas, compared to those areas without those restrictions. So if you have open fields, grasslands, or croplands, you're not going to be seeing reductions there. And finally, forest classification. So this is kind of a two-part system. It checks for trees, yes or no, and then it checks to see if those trees are conifer or deciduous trees. Studies have shown, several papers have shown that conifer trees can handle more snow load than deciduous trees. So therefore, if you are in a deciduous tree area, there is a chance for snow load to be higher. Now note that there is a reduction. This also goes into the leaf on, leaf off part of the WSSI. In the early fall season and in the spring season, we turn on or off a switch that will tell you if the leaves are on or off. It'll estimate that. So in a leaf on situation, where the leaves are still on the trees, the snow load index will be much stronger than when leaves are off. The impacts will be much higher. Now, that is an area of opportunity for the WSSI improvement. We are working to make that more dynamic. We've found some very interesting tools that we are hoping to incorporate in the near future builds of the WSSI. So that's definitely an area of opportunity, and we're excited to improve that part of the WSSI. So what is in the operational version of the WSSI, which once again, that went operational late September 28th. So the current version has been kind of frozen since October 4th, was when a lot of these final updates went into place. We held them stable for the entire experimental year and now going into this year as well. So it's the 72-hour summary of components and components, the CONUS, FEMA, states, and CWA base maps, the 24-hour summary and components graphics, the KML and shapefiles, and it should be noted that those have been actually simplified per media. We had a lot of requests from media partners that the KML files needed to be simplified to better be utilized in their packages, and we've done that. We did update the snow climatology in 2019, and once again, thank you to all the offices that reached out. A lot of the tweaks that were implemented in 2019 were direct feedback of WFOs, many of them in the central region. So once again, appreciate that. The flash freeze was updated in 2019. That has stayed the same. There has been some big updates to the interactive web display, which I'm going to walk through here in a second. And we have a more robust VLab page, and I want to thank Ian Lee of the Detroit WFO for his work there. He really crafted it and then showed us how to get it done on VLab, and hats off to him. I really appreciate his efforts there. Okay, so WSSI changes for 2021. There's been no changes to the core algorithms at this time. The KMLs have been simplified to reduce the size. We've talked about that. There has been some major website improvements, but a lot of our changes have been focused on training and future developments here. So we do have a full WDTD course now. I have it linked here. It's under the winter weather impacts. And then we also have gotten kicked off on we have a social science JETI grant with the Nature Nurture Center. That has started here in September. It got going. And the goal is to improve colors, definitions, and the appearance of the WSSI through social science. NWS personnel, partners, and members of the public will be surveyed and interviewed to solicit advice for improvements. And we will work closely with the social scientists at NNC to manifest those improvements into the WSSI. We're working with 6 WFOs and as well as headquarters. And those 6 WFOs are La Crosse, Grand Rapids, Boulder, Boston, Hanford, and Jackson, Mississippi. So we've had a great time working with those folks, and we're really looking forward to continuing the work there to improve the product. So some of the website improvements here, I have these highlighted, to the corresponding function on the website. I am gonna, this is kind of review, and I do want to focus here on the new stuff. So in this light blue area, I have now linked this to the archive static images. This was a request, and quite frankly, we should have done this way earlier, but it's now in place. So if you were looking for archive data going back, we have through this link, you'll be able to access the current season and the prior season worth of data for each CWA and the CONUS. You can grab that data there. If you need older data, let Jim Nelson or myself know, and we have a different drive where that data is archived. And then finally, the big improvement here is the retrieval of static images. So I want to thank Josh Weiss, who's a forecaster on the WPC Winter Weather Desk. He actually helped write this, pardon me, this algorithm to grab the data here. So a big shout out to Josh Weiss for his efforts here. So what does this retrieval do for you? So you can now easily grab your current, either the CWA or CONUS view, and for a couple of states, we have Illinois, Michigan, New York, and Nebraska state perspectives. You can now just grab those ping images. As soon as you select a zoom in area, you can use the radio buttons to flip to different components, and these are ping images, so you can copy and paste them, put them right into your PowerPoints or wherever you need them. One thing to note, though, the static images are only updating at 1, 9, 13, 19, and 21 UTC currently. We have pondered adding an additional time, and that's under review right now. So the WSSI VLab page, this is the public page now. Once again, thanks to everyone who's helped out there. On this homepage, we have a link right to the Esri story map that you can go through, and you can also use this feedback tool here to send us some feedback. The image viewer is going to be very similar to what is now on the WSSI homepage, static image retrieval. You can also access the archive here. The archive here might be a little bit easier to use in the VLab page, as you can use the date tool there to find your data a little faster. And then finally, we have our training links here as well. I keep flipping to the wrong thing. But we do have some training material links here, as well as the more detailed WSSI documentation, and the WAC course is listed there as well. So this is the WSSI moderate criteria versus 24-hour warning criteria. You'll notice that in the WSSI, which is here on the right, it's typically less throughout Central Region than the warning criteria. And this is one thing to remember about the WSSI climatology. It's based on the last 30 to 50 years of snow data, depending on the station, as not only the average 2-day snowfall, but the standard deviation of that. So these numbers are lower across portions of the plains in the Midwest than the warning criteria. I just want to remind that to everyone to keep that in mind, because the old WSSI system was very much, the language was linked to advisory and warning criteria, but we have intentionally chosen to go away from that. We don't want to try to tie the WSSI to a hard warning or warning watch threshold. So I just wanted to remind you that if you're seeing moderate, snow amounts in your areas, it is in most areas less than what the warning criteria is. And we can have a discussion about that, but I just wanted to point out that is what the current case is for much of the Central Region. The probabilistic WSSI, so right now what this is the probability of exceeding the snowfall thresholds for minor, moderate, major, and extreme. I have a link to the webpage here. This tool has been very, very popular with WPC forecasters, and we even had some Central Region feedback on this. So we're really excited. We got this going in February of 2020, and it's been fascinating to look at already with some of the early season activity. It uses, once again, the WSSI snow climatology threshold and the WPC PWPF. We are actively constructing a full fully probabilistic WSSI, but we don't have it's not completely developed yet, and B, we're not displaying that data yet, but I would anticipate an update on that in the near future for a fully probabilistic WSSI. One note about this page here, the probabilistic WSSI, is it is a internal tool to the Weather Service, so you'll have to use WPC credentials. This is just a link summary page, WSSI homepage. This documentation link is to the really in-depth detailed WSSI document. So that's the place to go if you're seeing a moderate flash freeze and you want to know why you're getting a moderate. That's the document to go to. Here's the PDD, the user guide, and then a link to that WSSI PWPF page. I'm kind of running short on time here, so I'm gonna just kind of skip ahead through the summary and ask for any questions or comments. Thank you.